The MTDCNC Podcast, sponsored by Langley Alloys, unique metals for demanding applications, providing first-class performance and an international service.
Welcome to the MTDCNC Podcast. Welcome back and thanks for listening. Today I'm joined by Nathan Phelan from LNS. Thanks for coming on the podcast.
You're more than welcome.
Nathan, yeah?
Happy to be here.
We really appreciate your invitation to come here. Where are we? You can hear, if I get the microphone out, you can hear some stuff happening because we are right in the facility, the production facility at LNS. What are you guys making here?
At the minute, we're making conveyors that we're shipping to Europe.
Yeah, absolutely. We've been filming for the past 2 days, doing factory tours, looking around the facility. You've got loads of processes: laser, bend, weld, fab, paint, assembly, shipping, everything. For all those Swarf conveyors going out to Europe. It's amazing to see. But we're not talking about that today. We're talking about, rather than production, we're talking about what a Swarf conveyor does. We're talking about something people don't really find that sexy, probably, Swarf management. Yeah, I mean, I'm really excited to talk about this topic, mainly because it's not really covered that much, I guess people want to talk about nice fancy machine tools, 5-axis stuff, but Swarf management, it's a little bit, it's not very well focused on, is it?
No, people sometimes forget about the Swarf removal, and it is a big part of the process.
Absolutely, yeah. And before we go into that, Nathan, what got you into engineering? A lot of people probably know you. You're a bit of a character. You go to a lot of different shows around the world. Actually, before I go into that as well, where are we right now?
We're in Barnsley, a little village at the side of Barnsley, Wunwell, in the heart of Yorkshire.
Brilliant. And so people can probably tell from your accent, you're from these parts as well.
People have commented a lot on my accent.
I bet all good things, I'm sure.
Some good, some bad. You never know.
Exactly. You never. Yeah. Maybe you can't tell in the moment what they really meant by something. But yeah,
yes.
It's okay. I'm also from here as well, ish, Rotherham, but I don't sound like it. But yeah, we're both pretty proud Yorkshiremen.
Definitely.
I guess.
Definitely.
So yeah, you're telling us a story off camera, which was how you got into engineering. Can you retell that, but with like the
clean
12
version.
rated? Yeah.
I fell into engineering a bit. I was actually studying, doing building studies. And then out of the blue, a family friend said there's a new American company opening up, Turbo Systems. They just recently opened up the factory here in 1999, building conveyors. I came for an interview one Saturday morning, and the rest is history. I've worked here since 1999.
It's amazing, and that makes it 26 years.
I had a bit of a sabbatical where I left to go back into architecture for 5 years, but yes, I've been 20 plus years.
It's amazing.
Yeah.
So despite a
LNS.
career change, you've been here for a long time. And that person who invited you was actually still here, isn't he?
He's still here. He's now part of the quality team that comes out of welding. He inspects everything that comes out of welding, every conveyor.
Which is amazing. Yeah, so he's been really kind as well to us walking around today. He's been really kind helping us get the best shots we can.
There's a good team here.
Absolutely. The whole production facility. So we've seen so much good stuff here. Great skill fabricators, great skill painters, laser, bend operators, loads of really good people here on the shop. But again, we're not here to talk. I mean, as much as I'd love to, you can tell I really want to, we're not here to talk about the production facility. If you want to learn more about the LNS production facility here in Wunwell, Yorkshire, you have to go check out the MTDCNC channel. We've got 3 videos coming out set here, and also we have another 2 podcasts, one with Tony Ficini, one with Tim Hardcastle, covering the production facility and the bar feeders from LNS, trying to reduce changeovers for manufacturers. But today, Nathan, we're talking about this less sexy topic maybe, Swarf management. Now, let's start right from the basics. Might sound like a stupid question. For those who don't know, probably many people do, what is Swarf?
Swarf is the metal chips that come off a part when it's being machined.
Absolutely. So Swarf can be loads of any kind of material, whatever material you're cutting.
Any kind of material.
And it can be really easy to manage or really hard to manage, depending on, I guess, the shape and the size, right?
Correct.
Yeah.
Correct.
Yeah.
All depends on the material and size, depends on the duty and the size and what level of filtration or non-filtration you actually want.
Yeah, absolutely. So different. So you can get chips coming off a lathe, which are pretty easy to manage. You can get big stringy Swarf. It's a complete nightmare to manage. And looking at when you generally have a CNC machine to produce the Swarf, you have a conveyor that takes it out.
Yeah.
You also get like screw augers as well.
Yeah.
Which are kind of built into the CNC machine tool.
Correct, which feed onto our hinge belt conveyors. Yeah.
Yeah, exactly. And that's for bigger machines that have got a bigger area to try and manage. But wherever the Swarf goes, it will go onto a conveyor that sticks it in a chip bin.
Yeah.
And there's actually a lot of different options you can choose when you want a Swarf conveyor. What are the basic options? What can people look at when they're speccing out a Swarf conveyor?
There is a lot of options.
What kind of options?
Well, for non-filtration, you're looking at a standard hinge belt, which is a standard duty or a super heavy duty, depends on the kilowatts of machine. If you're wanting entry-level filtration conveyors, which is our MH range, which is one of the best products for entry-level. And then for higher filtration levels, we do the SFC and microfines drum conveyor technology at 50 micron.
Right, it's great to get an idea of the range that's available to customers. What is filtration, and what is a hinge belt, and why are these two things different? Why does a hinge belt not have filtration?
Yeah,
so
good
tell me what a hinge belt is.
With the filtration side of the business, people get a bit misunderstood. With the MH, we do filtration at source, which means we have an integrated filter box inside the conveyor load, that any coolant that passes through the belt has to go through a fine mesh. And on the entry-level MH, we do it at 500 micron and 150 micron, which means depending on the filter box installed in the conveyor, the coolant passes out into the tank at that level of filtration, reducing tank clean-outs.
Absolutely. So that means that basically, when you have Swarf coming off a piece of material, it's not just Swarf, it mixes with coolant, and you suddenly have this really, really valuable thing that you want to keep and keep high quality, and this really, really valuable thing, which is the coolant, and this other thing that actually is also valuable as well, but it's waste, and you want to get rid of it and put it in a chip bin and take it out. You need to separate those things as best you can, and the standard way is with this hinge belt conveyor and your standard coolant tank. Now, what can happen with a standard hinge belt and a coolant tank as normal? That's like the normal setup.
With the standard hinge belt conveyor with no filtration, a lot of the particles are washed through not a lot, but some of the particles are washed through the belt and exit the slots in the conveyor load, and they can build up in tank. On a hinge belt design, typically on a 40-hour, 5-day a week, you can look at cleaning the tank out 10 times a year.
Wow.
If you're going with entry-level filtration, MH, 500 micron, it can be reduced to 4 times a year clean-outs. Now, with the filtration, when it's a MH conveyor, you're cleaning the conveyor. You won't have to clean the tank as much. With a non-filtration conveyor, the conveyors will run every day, all day. The tanks, you have to clean out a lot more.
Okay, interesting.
Entry-level filtration, for me, is the start of keeping maintenance to a minimum.
It's really interesting that. Let's back up a little bit. We'll talk about MH in a little bit more into like the filter box and how you clean them, the conveyors and all the procedures associated with that. But first, hinge belt and coolant tank now. There are like filters, you can filter sliding plates you can
filter
put in
screens.
And that's what I've never done that much coolant maintenance personally, unfortunately, though I've run CNC machines. There are filter screens involved. Don't they help with trying to reduce coolant clean out? How do they help?
No, not really. The filter screens on a hinge belt is basically to protect the pump from the Swarf chips. A standard filter screen on a hinge belt conveyor is 1,000 micron, so you're only
that's 1 millimeter.
1 millimeter.
Bloody hell, yeah.
You're only protecting the pumps in theory. It's not there to stop the tank filling with Swarf. Hinge belt is still letting all the Swarf through. The filter screen is there basically to protect the pump in that instance.
So with a standard hinge belt, you're basically just taking 99% of your Swarf away and leaving 1% in the tank, which will build up over time.
The numbers are a bit higher, but yes.
Okay, maybe, yeah. What are the numbers?
I'd say 85 to 90% of the Swarf will get exited through the hinge belt, but all the fine particles, the 10-15% will pass into the tank and build up on this filter screen.
And they'll get stuck in the corners, they'll get stuck everywhere inside the coolant tank. And that must be a nightmare to clean. You have to roll it out, you have to suck the tank out. What's the procedure with cleaning a tank out?
Painful.
Yeah, I can imagine.
Ideally, you'd remove the tank from under the machine, remove the covers, get the coolant out, however the customer wants to do it, and that, drain it down, and then get a shovel in, brush, clean the tank fully and remove all the Swarf particles that have built up over time.
It's pretty involved. You get the boiler suit on for that job, don't you?
Definitely. I don't have to do that no more, and I'm glad about that.
Yeah, I can bet. And when you're doing this 10 times a year, what's kind of I guess there's a cost associated with that with machine downtime. The machine's not available because you've taken the coolant out of the tank and you've got to go and clean it out. So how long How much is the cost in terms of machine downtime? And then if you could put a monetary figure on that as well, I guess.
You can put a monetary figure on it, but I don't. It depends.
Different machine hourly rates would mean different actual results.
I'll go on a standard non-filtration conveyor 10 times a year, 40 hours a week running. If you swap to entry-level filtration, we've analysed this, and 4 times a year cleaning it out.
Yeah, brilliant. So 10 times a year might take you 3 hours to clean out the tank?
It depends on the tank size, but 3 hours is, yes, definitely.
Yeah.
If
so
not
there's
longer
a
sometimes.
lot of time lost with this coolant tank clean out, which you simply don't need to do.
Yeah.
Okay, so tell me what the MH idea is you rather than shove in coolant and swarf onto the conveyor and then letting it just go straight down into the coolant tank if it can get through, what do you do instead?
The MH is using the traditional technology of a hinge belt, but we have integrated filter boxes inside the conveyor load between the belts. So the coolant passes through the belts, but the slot is no longer open. There's fine mesh, either 500 micron or 140 micron, depending on the coolant flow rates of the machine requirements. And this filters the coolant down, so any coolant that passes through the belt and the filter box is filtered down to either 500 micron or 140 micron. That means in the coolant tank, the 1000 micron filter screens are no longer really required because it's already filtered down to a level that will just pass through
those filter screens anyway.
Yeah.
Okay, so you're protecting the motors already at the conveyor belt size, and you're protecting the coolant tank from being filled up with most of the big macro rubbish, macro crap.
Yeah.
It's just the smaller stuff.
Yeah.
So what's interesting though is then the conveyor itself, that also has a lot of technology in it. How do you make sure that conveyor keeps itself clean?
With EMH, we've integrated brushes that are pot riveted to the inside of the belt. So in its natural motion of the conveyor taking swarf out, the conveyor belt is also cleaning the boxes on the top and on the bottom and keeping the mesh clear of any swarf particles.
Brilliant. So you're trying to maximize that separation, keeping the swarf inside the conveyor, not getting into the coolant tank, stick it in the chip bin where it belongs, meaning you extract more chips out that you can then hopefully go and sell later, send straight to the scrap man. So it's a really interesting technology. Let's move on a little bit. There's a few more in the range, a little bit higher up, because I think once people start working on really high performance applications, they really dig into this tech and don't just say, well, give me the basic filtration. They say, I need more than this, 140 and 500 micron. What do they say when they've got really fine applications? What are those applications and then what are the requirements?
Our highest level of filtration conveyors is 50 micron, and we have 2 options. We have the SFC, Superfine Compact Conveyor, which is the same size as an MH.
The one just behind us here, is it?
This is the microfine.
Microfine.
So this is the 50 micron drum conveyor, the traditional standard for 50 micron filtration.
Brilliant. And so what kind of applications are these super high-spec conveyors generally used in?
24/7 automated, lights out running, fine particle, volume, batch work, where the customer wants minimum downtime and lights out running.
And that's where you have the budget to invest in each piece of machinery to the maximum. Yeah. So you think about the bar feeding, you think about the conveyors, you think about parts catching, you think about everything else around the machine when you're trying to do such high volume production. Every aspect of the machine tool is really, really important. How does filtration help with that?
The filtration helps by saving the customer time in machine downtime. When they have filtration, it can ease the maintenance. It also improves coolant life. It improves tool life. Part finish quality is improved. If the coolant's a lot cleaner with filtration, the coolant that's getting recircled in the machine is better. It lasts longer. It gives a better part quality finish.
So the standard filter screens that give you 1000 micron filtration protect the motors okay. They're already protected. So the motors are protected as well with 500, 140 and 50. Yeah. But there's added benefits when you filter even finer. How does it help with surface finish quality? How does it help with those other aspects?
When it's down to the really low levels of microns, the coolant is not being pushed through the pumps. The pumps aren't wearing out as much because it's finer particles that's getting washed through. When they're coming out of the nozzles, the coolant has not got high micron size particles. It's really low
because you're firing almost like a gun, like out of a rifle.
Could call it shot blasting in a way. The finer the particles, the less coolant's getting blasted on that part that's been produced.
Brilliant. So if you're even interested in part quality, you need to think about actually the quality of the coolant you're firing at your really accurate component, and you'll find a surface finish component. So that's really, really interesting. When it comes to actually you see a lot of customers. Do you see a lot of customers now doing maybe more micro machining, or with really, really tiny coolant holes, or high pressure coolant as well, where they're actually requiring more filtration as well for those aspects?
Some of the high pressure pumps cannot cope with anything above 50 micron. Some of the older style pumps can take up to 1,000 micron particles through the pumps, but the shelf life of that pump is deteriorated the bigger the particle size.
Yeah, so massively reduced when you're firing those shots through it, basically.
Yeah. Some high pressure pumps will only run at 10 micron, and we have to add further filtration onto the 50 micron to keep it clean.
Yeah, absolutely fascinating. Let's jump around a little bit more to kind of the kind of customers who are using the higher spec conveyors from L&S. There's quite a few in Europe. I know you maybe don't want to mention too many names, but what are those customers generally doing? What kind of parts are they making when they need this super fine?
A lot of medical industry, aerospace. We do MOD work. We have a lot of high filtration, entry-level filtration. All these customers. It depends on the nature of the application, sometimes the material, and the volumes.
Yeah, absolutely. So that's when you're not just doing the big macro swarf management, you're thinking about the micro fine swarf management as well. Yeah. Really interesting applications. For those customers then who are kind of listening to this, who are probably 80% of the world, they're kind of sub-con shops, or they're producing products but not in massive volumes and not with massively tight tolerances and surface finishes. Why should they choose a conveyor belt with filtration versus the standard hinge belt everyone's been choosing for I don't know how many decades?
The entry-level MH filtration is a proven product that will improve coolant maintenance, less maintenance. For me, the hinge belt will always have to support the hinge belt, but MH really gives a good price point for entry-level filtration to give a customer a quick return on investment within a couple of months sometimes.
Yeah, brilliant, because you're saving that machine downtime.
Yeah.
If machine uptime is critical for customers, you need to think about every aspect of your machine tool, and the swarf conveyor should not be something you're ignoring. Yeah. It's definitely a critical part of it. So yeah, really interesting discussion. Thank you so much, Nathan, for going through kind of how L&S are trying to help customers with swarf management, both at kind of a really high level with really fine filtration, super high volumes, super high requirements, and then back together box standard where we all live, which is the 80% of us, which is just trying to stop people needing to clean out coolant tanks so much, which is definitely going to help operators as well, make their lives a little bit nicer as well.
As an apprentices that used to clean out the tanks and that, yes, I see the benefits firsthand of what the MH gives us.
I'm sure all the apprentices are thanking you guys. Brilliant. So yeah, thank you so much for listening to the MTDCNC podcast. We've been here at the L&S production facility, part of a series of podcasts here from Wombwell near Barnsley in Yorkshire. Really proud to be here looking at UK manufacturing, making products that are shipped out to the whole of Europe and sometimes the world.
Sometimes the world, yeah.
Sometimes the world. So yeah, and that's just to reiterate, thank you so much for coming on the podcast with us, Nathan. We really appreciate it.
Thank you for having us.
Thank you for listening to this episode of the MTDCNC Podcast, sponsored by Langley Alloys, specialists in a wide range of exotic materials for any application for all your engineering needs.